Alright, so now we're going to move into some dividing exponent properties. So we're going to start with the quotient rule. And basically what the quotient rule says is if I have same bases, so like a to the m over a to the n, that is going to be equal to a to the m minus n. And if you think about it, division is the inverse of multiplication, and we multiplied same bases we added. So it really only makes sense that when we divide same base, we'll subtract the exponents. Now, maybe you're like, but why does that work? So if we do a to the fourth power over a to the third power, then we would have a times a times a times a over a times a times a. We would divide out 3 a's, top and bottom, leaving us with just one a. Which is the same if I would have done a to the 4 minus 3, that equals a to the first power, which is just a. Now, we've worked with negatives, and because we've worked with negatives and now we have this rule, I just want to let you know that if we are working with exponents, and we're doing division, and you have, say, bigger exponent in the bottom than in the top, to save yourself some time, always keep your base where it's bigger. So 10 is bigger than 4, so I'm going to keep my a in the bottom, and I'm going to do 10 minus 4, and something has to be in the top, so we'll put a 1. Now, why would I do that? Because if I do everything to the top, then we would have gotten a to the 4 minus 10, which is a to the negative 6th power, which when we have a negative exponent, we have to move it. Right now we're in the top, so we would move it to the bottom. It is the same process. Notice we get the same answer in the end. But in my opinion, I'm less likely to make a sign error if I subtract to the bigger number. So that's my suggestion. We'll probably get a little bit of practice in here. All right, so see, I told you we're going to end up with fractions showing up, and we're just going to work with them like we know how to do. This is going to be x to the 5 halves minus 2. I have to have same denominator, so I'm going to think of this as 2 over 1. And so we're going to have x to the 5 halves. Well, actually, I'm going to do this math off to the side. 5 halves, and then 2 in halves would be 4, minus 4 halves. Because when I multiply the 1 by to get 2, I've got to multiply the top. So 5 minus 4 is 1, and 2's stay, because when we add or subtract fractions, the denominators stay. And so now we get x to the 1/2. And that is our answer. All right, so on the second one, this is what I was talking about in the last slide. The 5 is bigger, so in my opinion, we're going to keep the m on bottom. The 4 is bigger for the n's, and so the n is going to go on top. So we're going to do 4 minus 3 on top, and we're going to do 5 minus 2 on the bottom. 4 minus 3 is 1 n, so we're going to have just n. And 5 minus 2 is m to the 3rd power. And that's our final answer. And I didn't have to mess with the negative because I went ahead and kept my m to the 5th on the bottom. All right, so back to some scientific notation just so that we get some of that practice in as well. Population density describes the number of people per unit area during the year. The population of Angola was 1.21 times 10 to the 7th people. The area of Angola is 4.81 times 10 to the 5th miles squared. So what is the population density? So people per unit would mean people on top, 1.21 times 10 to the 7th over the area, which is 4.81 times 10 to the 5th. And so we're going to do some division. We're going to do 1, right now we're just going to leave it, 1.21 over 4.81, and then that's going to be times 10 to the, and we're going to do 7 minus 5. So 1.21 divided by 4.81, I have equals. I really should make those approximate because we're going to round. Approximately 0.252 times 10 to the 2nd power. Now, I can't leave it like this, so there's 2 ways we can do it. I can shift my decimal 1 to the right, which would make this a 2.52. And if I'm going to shift it to the right, that's 1 less I'm going to need to move, so this becomes times 10 to the 1st power. The other thing is I could just create this in standard form. So in standard form, this is approximately 25.2 people per square mile. Then the way I did that was this was 10 to the 2nd power. We move it 1, we move it 2, and that's how I get this 25.2 people per square mile. Foot. That was silly, Mrs. Cartwright. All right. So either way, just look at what Math Excel is asking for an answer. All right. That's what you just need to be careful of. And that is it for our lesson on dividing exponents. Until next time, 8th graders, stay classy.